Okay, this is a quick video about operations with fractions. Okay, so we're just going to go over how to add and subtract and multiply and divide them. All right, so let's say you have a fraction 3 over 4, and you want to add 5 over 8. To add fractions, we need to get our denominators the same. So these two guys right here, we want them to be the same. Then we can add the fractions together. So to make them the same, we're going to multiply or divide them by something. Usually we're going to multiply them. So I'm thinking in order to make this 4 into an 8, I'm going to multiply this entire fraction by 2, which I can do because then I'll just be creating an equivalent fraction. So if I multiply that whole first fraction by 2, I will get 6 over 8, which is actually exactly the same as 3 over 4. But now what I've done is I've made my denominators the same. Once our denominators are the same, we can just add the numerators together. So 6 plus 5 is 11. 11 over 8 is the answer, which you could just leave as an improper fraction. Or if you wanted to, you could rewrite it as a mixed number. But I'm just going to leave mine. Okay, then subtraction. Subtracting fractions is the same as adding them, but you're subtracting. So we still need to get these denominators to be the same. I don't see an easy way to do that with a 7 and a 3. So I think the only way we're going to be able to do that is I'm going to multiply this fraction by 3, top and bottom, and I'm going to multiply this guy by 7. I know that's going to produce the same denominator because 3 times 7 is the same as 3 times 7. So both of my denominators are going to now be 21. And when I multiply the top by 3 over here, I get 18. And when I multiply the top by 7, I get 14. So I just chose something to multiply them both by to make them exactly the same. In this case, I actually multiplied the denominators by each other's denominator. And now I can just subtract the numerators. So 18 minus 14 would be 4. So my final answer is 4 over 21. And you always want to check in your final answer, you always want to make sure your fractions are in lowest terms. So is there anything that 4 and 21 are divisible by? I don't think so. Okay, so that's adding and subtracting. Let's try multiplying and dividing. Okay, so if you want to multiply fractions, all you do is you multiply straight across. So in order to multiply these fractions, I would just multiply across. So 5 times 2 is 10. 8 times 3 is 24. So I don't need a common denominator. I just multiply the numerators together and I multiply the denominators together. Now I can see that this fraction is not in lowest terms. I'm noticing that they're both divisible by 2. So 10 divided by 2 would be 5, and 24 divided by 2 would be 12. So now my answer is in lowest terms. Now there is a way that you could simplify it before you multiply it. If you don't feel good about this way, then you do not have to do it. But there's this thing called cross-reducing. So I can see that I have an 8 here and a 2 here. So I could actually reduce this fraction before I start. And the reason I can do that is because 5 over 8 times 2 over 3 is actually the exact same thing as saying 5/3 times 2 over 8. I can flip-flop them because multiplication doesn't matter the order I do it in, right? 5 times 2, 2 times 5, 8 times 3, 3 times 8. I'm going to get the same answer. So I can actually reduce things that are on the top and bottom. So if I see the 2 and the 8 are both divisible by 2, I could actually divide them by 2 before I even start. So now I would end up with 5 over 4 times 1 over 3, which would end up equaling 5 over 12, which is the same answer. So you're not you're just reducing before you start. And the only reason I like doing that is if my fractions are really gigantic, it's just harder to reduce at the end because they'll be even more gigantic at the end. So sometimes it's nice to reduce before you even start. Okay, the next one, let's see what happens when we cross reduce. Well, actually, let's do it the other way first. So just multiplying straight across, 4 times 3 is 12, and 5 times 10 is 50. And now I would have to reduce that. So now I start to think like, okay, I know they're both divisible by 2. Anything else? That might be it. So if I divide the top and bottom by 2, I would get 6 over 25 as my final answer. So that wasn't too bad. But if I wanted to, I noticed that the 4 and the 10 are both divisible by 2. So I could actually divide that by 2, divide that by 2. And then I end up getting 2 times 3, which is 6, and 5 times 5, which is 25. So I get the same answer, but just a different way to do it. Okay, so that's how you multiply fractions, just straight across. And when we divide fractions, which actually won't be that often, we actually change our division sign to a multiplication, and we multiply the reciprocal. So we actually multiply by 7 over 4. We actually flip that second fraction around. So we actually, for dividing fractions, we actually change it to multiplying, flip this second fraction, and then we just do what we normally do, like multiply the fractions together. So 2 times 7 is 14, 5 times 4 is 20. Reduced to lowest terms, I could divide them both by 2. 7/10 is my final answer. And I could have reduced ahead of time because the 2 and the 4 are both divisible by 2. Just one more thing to note, the only time you can cross reduce is if you have something on the top and something on the bottom. Right? You could never cross reduce if it was like 2 over 3 times 4 over 7. Like these guys are on the same side, so you can't reduce them. So nothing on the numerator and denominator would simplify. Okay, so that's how you divide fractions. And multiply and add and subtract. And don't forget to always, always, always make sure your fractions are in lowest terms.